I've got to feed all the animals around the homestead, as always. And then I'm going to get to work building a cheap and easy 12-volt solar system for you guys. When you're building a 12-volt solar system, there's only a few different components you need. A battery bank, a charge controller, solar panels, and an inverter. I'll put up a little diagram that'll show you guys roughly what gauge wire you want to use when you're connecting for certain lengths and for certain amperage. This is frugal off-grid, and so part of what I do is I try to do things as cheaply as possible while still remaining effective. So sometimes frugal doesn't mean spending the least amount of money, but you want to spend the least amount that you can to get the most utilitarian use out of something. And so I'm going to make a few recommendations on how to get yourself a cheaper system that still will do the trick. It's no secret that a lot of the best lithium batteries are built in China now, which means you can get quite a few of them at a pretty good discount, especially if you can buy them on Black Friday or any one of those really large sales that they might have. Most of the solar panels around my homestead were used. Most of them I just bought used for like $60 a panel for like 240 watts. So they're used panels that work perfectly fine. That's one way that you can save a lot of money, because solar panels are not cheap. The wires that run from the solar panels to the charge controller, those are just going to be 10 AWG, or a roughly 10 gauge wire. What's important is to make sure the wires that go from the inverter to the battery bank and the wires on the battery bank are large enough to safely contain the amperage and voltage that'll be running through them. Not only are Chinese manufacturers making really nice batteries these days, well, they also make really nice inverters and charge controllers. Bouge RV is one of my favorite cheaper brands. I have been using one of their charge controllers for several months now. A very large charge controller, the largest I've ever had, in fact. I actually have one of these set up in my camper van. You can check out that video here if you'd like to. And at the end of the video, I'll tag another video of installing the inverter in my van. This is the Bouge RV MPPT solar charge controller. It's a 100 amp. Now, you can get really cheap charge controllers that are PWM and not nearly as efficient and whatnot. If your money's that tight and you have to do it, you can get some. Just read the reviews. You can get one that's pretty cheap. But a PWM charge controller is like 30-40% less efficient than an MPPT charge controller. So say you buy a 100 watt solar panel and you're running that into your system with a PWM, it's not going to be nearly as efficient. You could simply upgrade to an MPPT charge controller, and that alone could make your system handle the things that you need it to handle, while the PWM may or may not. You also don't need the 100 amp charge controller. This system I'm showing you here is what I would do personally if I was going to start from scratch and I wanted a nice system that is very expandable, that's still pretty easy and relatively affordable. But you could definitely go much smaller on the charge controller just to get started. However, the real benefit to this is because this is a 12-volt system, you need the largest charge controller possible if you're going to put in 1,000, 2,000 watts down the road. And once you get to 2,000 watts, if you get to the point where this can't handle that in 12-volt anymore, well, switch that system over to a 48-volt system. You're ready to upgrade, and then this system could hold maybe 3 times, or it could take maybe 3 times as many watts coming into the system. This is the Bouge RV Pure Sine Wave 3000 watt inverter. You really don't want to go much smaller than this if you're actually running a homestead or whatnot, but you could get by with something a little smaller in your camper van or just to get started. This inverter. I've been running one of these for quite some time now, this exact inverter. I run the flux core welder on that, welding 1/8 inch metal, running long beads, and it never quits on me. So it will get you by, you know. Now, if you're a professional welder, you know, you'll want a larger inverter so that you can run a larger, you know, all the different settings and everything, 220, so on and so forth. But this will get you by for the most part. You can make things work on your homestead with a 3,000 watt inverter. This day and age, you pretty well don't want to get anything if it's not a pure sine wave inverter. That sends just nice, clean, pure energy to your system. If you buy one that's not pure sine wave, from my understanding, it's more like an analog signal. So it's not a smooth digital signal, and therefore certain electronic items certainly won't run as good, and it could be actually unsafe to use for those electronics. Something, by the way, that I really like about this, well, first of all, this might sound funny, but the plugs, they're tight. They really hold, when you plug something in, they hold it tight. It doesn't get pulled out. And then you can hardwire something in. So in my camper van, I have an air conditioning system, and you know, it's like leg one, you know, neutral, ground, you know, how you wire a system. And so I can run the cord in underneath the inverter and just plug it directly in, hardwire it in, and that way I never need to worry about it getting unplugged on accident, and it's just straight into the system. And there's some utilities that would be just the easiest way for you to run something in, and not a hugely common feature on a relatively small inverter. So something I really like. They also have the display that you can run. You know, it's got 4 or 5 feet of cord, so you can run this, cut a nice neat hole in the counter, put it there. It'll tell you exactly what all your levels are. With all of that specific information out of the way, it's really not that difficult to connect a little solar system. The first thing we're going to do is cut some wire to wire up our battery bank. You could use one simple 12-volt battery, but 4 will give you a lot more amp hours, which means more power that you can store, and that'll get you through the night. I have a space over here where I used to have a 48-volt system. I'm just going to clean up this wiring, and I'll use the 2x4s that are already on the ground. That way I can keep my batteries up off the ground in case there's a flood or something. And we'll just set up a really simple system right here at the entrance of my shop, which will actually allow me to plug in as a backup and to use it for shop lights and all kinds of other things. I've actually been relying on my camper van solar system for probably about a year because my 48-volt system failed, and then this huge power station I had failed, and I just haven't put anything in here that's reliable enough to serve any justice. But this little 12-volt system, guys, will be a huge backup system for my little homestead. I've cleaned up this space in my shop so I can elevate these batteries, and it gives me a wall space to connect a controller and an inverter. I had a 48-volt system here, and so I have a negative cable with a shunt, so I could connect a shunt to this, or a readout eventually. And then I also have a fuse, so for the positive side. So when you connect your inverter to your battery bank, you can put in a fuse here to prevent damage to any components. You'll just blow the fuse. If you can't afford nice clippers, crimpers, strippers, wire cutters, and all the tools that make this job so much easier, it can be done. It just is going to take a little bit more work. You know, in order to do large crimps like this, you need a large crimper. In the past, I've had to use a vise or a hammer and a large flathead to crimp the ends of the wire. I know what it's like to start over from scratch, and so I don't even have a heat gun or a tool for the heat shrink. I just use a lighter. Okay, feed the wire through. So the batteries are connected in parallel simply by running a negative to the negative to the negative to the negative. This extra cord, this comes off, and I have it dangling safely on the negative side for now. This will go to the inverter. So if you see the battery bank, the negative comes from that side, and then the positive will come from this side to the inverter. And the only other thing I need to connect directly to the bank is the charge controller. So I'll connect the charge controller, negative, positive, and the inverter and charge controller will be up here. And then I simply need to wire a solar panel into the system. When you connect the inverter, you're always going to see a little spark like that, so don't let it jump scare you too much. I'll have to cut a longer one for the negative side, and we'll make it black anyway then. If you work with solar, you may as well get a roll of 10 gauge wire and just always have it on hand. I was just trying not to break into a new roll, but all of the wire I've used so far is scrap material, like old projects, and so it's nice to be able to reuse as much as you can. And then it looks like I need a little stretch of black wire here. So we'll pull off a piece that's long enough to connect to here and run around without being stretched tight. So about that long should be just fine. I can save the rest of that for later. This end has already been stripped, so we could put a connector on this end here. So negative from the battery bank to the negative on the charge controller, and positive from the battery bank to the positive on the charge controller. And then I just have to run the solar panels in, negative and positive, to the charge controller, and the system will be complete. Okay. Run it back behind the batteries here. So that's everything that we need to connect to the battery bank and to the wall, and now we just need to run solar panels into the system. A sure way to destroy your entire system is to connect it incorrectly. So no matter how sure of yourself you are, things can get crossed along the way between a solar panel array and a charge controller, and the different DIY wiring you do. Things can get mixed up, and I've done it. I've destroyed a system. It was 100% my fault, and it could have been avoided if I just pulled out my voltmeter and use your positive and negative here. So here's a positive line apparently coming in, and a negative line, and these are a solar panel array that I have on the roof of the shop. It's a 500 watt. So I put the positive tester and the negative tester accordingly into the positive and negative, and you can see on the display 69 volts. So I have to have it set to 200 volts to read that. If it was down in 20, it won't give me a reading because there's more than 20 volts coming in. So bump it up, you got 69.9, so 70 volts coming in right now. And you notice that it's positive. That says that because I have the positive in the positive, the negative in the negative, and the reading is positive, that says that the wires are not crossed, that this is in fact positive and negative, okay? And now if they were mixed up, if you still had these in there correctly, positive to positive, negative to negative, and it reads negative 70 volts coming in, your wires are crossed. Mine are not. So that's a good way to be absolutely sure that this is in fact your positive, this is in fact your negative. I guess this is the settings key because it has a gear on it. Boom. We do not have a gel battery. What is select? We want lithium. Lithium, okay. And I bet you put set to enter, or use up and down to select, and then long press set key to save. Boom. Okay, well now we're set for lithium batteries. 93% charged. So we're running the shop lights, which, man, it's been so long since I had the shop lights in here running, and they're real nice. It's super bright in here. Once you have everything connected correctly, you'll be able to see the solar panel display, and there's little lines and an arrow showing that it's charging the battery. And when you go through, you can see 39.7 volts currently coming in, 40 volts. It shows E00, that means no error. 14 Celsius right now. 2 watts, I believe, is what it's saying. 2 watt hours so far, because I just connected it. It's at about 10 amps. 96% charged. Now it says 98. It's definitely getting charged up pretty quickly. So 13.2 volts overall. And then this little guy for the inverter, this display just plugs into the top with an old telephone jack. It shows the voltage. It shows that there's 120 volts of output, and 133 watts are being used right now from the shop lights that are being run off the system. And it shows a battery level as well. And you can turn this on or off, and there's a backlight. See, so you can turn that light on. Oh, you can just, that's interesting. You can just turn everything off with that button. I didn't even know. Don't forget to check out my website for my free ultimate guide to off-grid living, and tell me what I did wrong below. I'm no electrician. Tell me what I did wrong. Tell me what I did right. Tell me what you like about the build and what you don't like. Look how bright the shop is. Let me show you the shop lights. Look at this. Just nice and bright. It's been a long time, guys, since I had power in here. And this is phenomenal. This charge controller and inverter is the exact same power system I have in my camper van. The only difference is in here I have 400 amp hours, and the battery bank in the van is 800 amp hours. And I have my air conditioning unit connected to the van, and it has its own solar panel array. But once the sun goes down, my air conditioning unit relies on that system over there. And it runs 24/7, guys. And so being able to move some things over here, or just plug in stuff in here, or be able to run these lights anytime I want, it really is going to be nice and convenient. And it's tried and true, this system. This is the exact system I've had in my camper van for quite some time. So now I have 2 systems with the Bouge RV 100 amp MPPT charge controller and the 3000 watt inverter, both 12 volts. And I know I'm no electrician, and there are some hardcore electricians out there that know so much more than I do. And they will tell you often, hey, you should just go straight to a 48 volt system. I know they say that a lot, but I disagree in a lot of scenarios if you're trying to be cheap or frugal. And one of the arguments is if you get a 48 volt system, the copper wiring is cheaper. But I'm telling you, starting out here off grid, I had no money or nothing. And being able to just grab a 12 volt charge controller, a 12 volt inverter, a little bit of wire here and there, that's the most expensive part. And it's not even that bad anymore. And one battery here. You could get one 100 amp hour battery, a month later get another one. And it's not ideal. It's best to get maybe 8 batteries all at once, but you could, if this is what you had to do to get by. 1 battery this month, 1 battery next, but you'd be able to connect it immediately once you have your charge controller, your inverter, and 1 battery. You can start to add batteries. You can start to add panels. You know what I mean? It makes it more realistic for an off-grid person that's going to piece together a system. And I've shown a lot of power stations on my channel, guys. This is still the cheapest way to get a lot of storage for your power, a lot of power for your welding machine, etc., your power tools and whatnot, and a largely expandable charge controller that, it'll go up to a couple thousand watts. And then once you outgrow it on a 12 volt system, now change into a 48 volt system. Now you've got all kinds of components and whatever. I truly believe that that's a good way to get started. Check out the links down below, guys. You're helping support my channel if you use my link to get one of these. If you're going to set up a system anyway and you found the video useful, go snag these items using my link. It'll help me continue to build my frugal off-grid homestead. And I'll catch you guys on my next video.